In our previous lectures, we have understood the basics of pointers and then we have written down a computer program to demonstrate the working of pointers. But we have not seen any application of pointers as of now. So in this lecture, we are going to look at one of the very important application of pointers. So let's get started. So to demonstrate the application of a pointer, here is this program available called as variable modifier. So we are supposed to write a program. Basically, you are supposed to write a function that will modify a given variable, that will actually update the value of a given variable. So I've already created the main function here. So this is the main function. In the main function, there is one variable a defined and the value of a is 10. What I am supposed to do is to modify this value 10. Let's assume that I would like to increment the value by 5. So 10 plus 5, the answer should be 15. But I would like to do that by writing a function. I should create a separate function to actually update the value of a by 5. Okay, so here I'm just printing the value of a before performing the modification. So this would print 10, and then here in line number 12 I'm supposed to write a function call which will modify the variable a. So in order to do that, I need to first of all create a function. Let's create a function just before the main function. Let me call the name of the function as modifier. Let the return type be void modifier. Okay, and it will take one argument. So let's say that argument is x. Okay, x is what I'm going to modify, and then I just modify the value of x by 5. So I'll just write x is equals to x plus 5. So I'm adding up 5 to the variable x. Okay, so now this is done. I'm done with my function. The modifier function is done. So what I'm supposed to do is in line number 16 here, I need to make a function call. I need to call to this function modifier. So how do I make a call to this function? I'll just write modifier, name of the function. I'll pass the value, right? The value that I'm supposed to modify is the value 10. So I'll pass the variable a. A would pass the value 10. Okay, so 10 would be stored in the variable x. So then it will try to modify this x, which is 10. So 10 plus 5, the answer is 15. Once I make a call to this function modifier by passing the variable a, what I do is in line number 17, I print the value of a one more time to check if I get the modified value or not. Okay, so let's try to compile this code and see if it works fine. Compilation is successful. Okay, now let's try to run this code. You see the output here, right? Before I make a call to modifier, so before modification the value of a is 10, and after modification also the value of a is 10. That means the value of a is not updated. Now what could be the reason? Why is the value of the variable a not updated? One of the reasons you may think why we are getting the same answer even after modifying the variable is because here you may think that this variable should be named as a and not as x, because we are actually trying to modify the variable a and not the variable x. So let me try to change this variable x to a. So let me make it as a, and here instead of x equals to x plus 5, let me make it a equals to a plus 5. Okay, now let's see what happens if I do this. Let me compile this code. Compilation is successful. Let me execute it. Even after changing the variable name from x to a, it did not work. Still I'm getting the same output. That is, in both the cases the output is 10. The variable a is not modified. So what may be the reason for this? Let's try to understand in more details. Now this program starts executing from the main function. In the main function there is one variable that I'm creating. That variable is a. So it will occupy the space in the memory. Let's say it is occupying the space, starting address being 1000. This address is allocated by the operating system. And inside this address, the value 10 is stored and the name of this memory location is a. Now I encounter this printf wherein I print the value of a. So it will print a equals to %d. Here the value of a is 10. So it will print 10. So a equals to 10 is printed. Now it will make a call to this modifier function, right? And then it is passing the value a. So it will pass this a to this variable a in the modifier function. Now the modifier function will have its own memory wherein it will be storing its own variable. Now this variable a is local to this modifier function, so it will be stored in the memory area of the modifier function. So now this memory is called as a. Okay, and let's say the starting address of this is 2000. Okay, and now because I am passing this a from the main function, so I am passing the value, so therefore it is called as call by value. I am calling to this function, I am passing the value. Okay, so a would be nothing but 10, right? So this 10 will be copied and will be stored here. Okay, so what I'm trying to do is I'm trying to make a copy of a, right? And this a belongs to the modifier function, and only the modifier function can access to this variable a. It is local to this modifier function, and this a is local to the main function, and only main function can access this a. So here I've passed the value a, and in the modifier function this 10 is stored in the variable a, which is local to the modifier function. Now in the modifier function I perform a equals to a plus 5. So this variable a in the modifier function will be updated by 5. So 10 plus 5 would be 15. So this will be updated to 15. Okay. So now this variable a is 15, but this variable a in the main function is not changed. I was actually trying to modify the variable a in the main function, which is not modified. It is still 10. Right? So once this execution is done, the control will come back to this function. So modifier function is done, and then it will execute this printf, last printf. It will print the value of a. So whenever it will print the value of a, it will see the value of a is 10. So it will print a equals to 10. This is the reason why the value of variable a in the main function is not modified, because I am passing the value of a. I am passing 10 and I am not passing the entire variable a. This can be fixed by making a call by reference. Now in case of call by reference, you do not pass the value, rather you pass the address of the variable. Okay, let's look at this example. Let's take a in the main function. It is allocated in the memory space address 1000, and the 10 value is stored in this. Now what happens is, here you see, just look at this modifier function. I am passing the address of a. So I've written down ampersand a. So what is ampersand a? This is the address of a. Ampersand a is 1000. So I'm passing the address. Address is sometimes referred to as reference. So this is call by reference. I'm passing the address of the variable a and not the value. Okay, I'm not sending the content 10, rather I'm sending the address itself. If I'm sending the address, the data type of this argument should be a pointer, because this address is nothing but the pointer. Okay, so it's a pointer to the integer variable, because it is storing the address of an integer variable. So this address will be stored in PA. So this is the variable PA, which is local to the modifier function. Now this is the pointer. This is the pointer. This is the pointer to what? Pointer to integer variable. So int star PA will create a pointer to the integer variable, and it is now capable of storing the address. So which address will it store? It will store the address of a, which is 1000. So 1000 will be stored in this location. The content of this variable is 1000. How did it get 1000? Because I am passing 1000 here. See, whenever I am making a call to this function modifier, I am passing the address of a, which is 1000. So 1000 is passed here in PA. So PA is holding 1000. That means I can say PA is now pointing to a, right? PA is now having the address of a. Now once you have got the address of a, you can directly modify this value inside this address. How do I get this value 10? By using this pointer, I can just write star PA. Star PA is as good as writing a. Whenever I write star PA, first of all it will look at the content of PA. Content of PA is the address. So whenever I write star PA, it will just follow this address 1000. It will go to this address 1000 and see the content inside this, right? So the content inside this is 10. So whenever I write star PA, I'm meaning the variable a that is there in the main function. I'm talking about the same variable a, right? So just look at this star PA plus 5. Star PA plus 5 is what? What is star PA? Star PA is as good as writing a. Which a? This a. So what is a plus 5? That is 10 plus 5. So this entire thing would be 10 plus 5, which is equals to 15. Now 15 is stored where? It is stored in a. Star PA is nothing but a, right? Star PA would take me here. So now it is actually modifying this and updating this to 15. Now if you print, you will see before the modification here, before the modification a is 10. Once modification is performed, once you call this modifier function, you are calling by reference, the value of a is now modified to 15, and once you print it here, after modification, a is how much? It is 15. Now this is only possible when you pass the address of the variable. This is where pointer is used. So whenever you would like to perform the modification in the original location, not in the copy, in that case you have to pass the reference to that variable. Like in this example, we have passed the reference, the address of this variable a. Therefore, the function that is receiving this address should be able to modify this variable. So this is one of the applications of pointers. In this lecture, we have learned the difference between call by value and call by reference. We have seen what is the drawback of call by value and how it can be overcome by making the call by reference. Call by reference is nothing but a function call wherein you make a call to a function and you pass the address of a variable as an argument. Okay, so that is what we have learned in this lecture. So that's all in this lecture. Stay tuned.